Uh, Good afternoon, everyone. I'm Ferhat. I'm an engineer on the Flutter Web team.
And I'm Liam Spradlin, a designer on material design and a design advocate.
And as developers and designers, one of our biggest challenges today is not only building for multiple platforms, but also building for multiple form factors. And Flutter started by supporting two of the most popular platforms, Android and iOS. Today, Liam and I would like to talk about bringing the same productive, modern developer experience to the web. So we'll be doing some live coding and giving you some product updates. So here are some of my favorite reasons for using Flutter Web. So the first one is deployment. Ease of deployment has two main benefits for your projects. The first benefit is that with no install friction, more of your users can try out your product, and you can increase user adoption. The second big benefit is being able to quickly iterate on your applications. At Google, some of our products run hundreds of experiments simultaneously, and we frequently update these experiments. The web is a great way of delivering this quick iteration cycle to improve your products using the web.
And most of all, creating really expressive, dynamic experiences for the web can be challenging. And as Matthias mentioned in the keynote earlier, Flutter allows us to jump to the interesting part of solving these problems by shortening the cycle of iteration between designer and developer. And I think a lot of designers in the room might be familiar with hearing no on these kind of interesting dynamic experiences, either because of technical feasibility or product timelines or other kind of logistical reasons. But now it's easier to say yes to these experiences and extend them to the web.
So to show you how Flutter enables these rich interactive experiences on the web, let's take a look at how we build websites today. So typically, we use HTML templates and CSS to build up our element tree, and we pass it on to the browser. And the browser uses HTML and CSS to lay out our elements and paint them on a web page. Flutter, on the other hand, was architected with the idea in mind that the build, layout, and paint cycle are fully available to developers. So Flutter's APIs expose the whole rendering pipeline to you. And this is what enables these rich experiences to come to the web as well.
As an example of this, we can look at one of our material studies called Shrine, which has this really highly expressive identity. And that identity is expressed through things like custom cut corners on surfaces that are elevated, custom image treatments, typography, and a lot more. And as Ferhat was saying, having full access to the paint pipeline and themes in Flutter allows us to implement this really easily. This is another example of a custom component and interaction where the shapes of the buttons and the bottom bar are being manipulated based on user input. So the shape changes are actually conveying something to the user about states.
There are some wonderful upcoming web standards, such as CSS Paint, that enable some of these at the platform level. With Flutter, you can start building these experiences today.
And to get started on an example of this, just for a show of hands, who here is familiar with this shape on the screen? OK, cool. So the golden ratio is a concept that some of you are familiar with. And it's a mathematical ratio that we see reflected in the common geometry all around us, from things like art composition to seashells, to ferns, to pine cones, and even broccoli. It can be described as a progressive spiral like this, where each segment has shares a ratio with its neighboring segments. And specifically, each segment here shares a 1.618 aspect ratio with the following segments. And so because this is a rigid mathematical structure that can set the parameters for harmonious curves and shapes, it can also be a useful tool in other kinds of composition as well, including maybe the layout of components on a screen. So now we'll get an idea of how that would look in code.
Mm-hmm. If we can switch to, yes. So let's do some coding. I've created a sample here where I'm building a golden ratio widget. And I'm going to take advantage of some of the built-in building blocks in Flutter to create this ratio. So first of all, the golden ratio width and height ratio on it is, let's see, 1.618. So I'm going to use the aspect ratio widget, and I'm going to create a child where I subdivide the two areas on my widget by using a flexbox. And inside my aspect ratio widget, I want to have two areas that have the exact same ratio. In this case, I'm going to use flexible with a flex value of 1618, since it's an integer. And I'm going to place our primary child widget here and add another area to my flexbox. Okay. So let's sorry. All right. Oh. 1 second, let me. Okay. So now, when I resize this widget, I should be able to see that the ratio between the width and height is preserved, and the area between the two elements are preserved as well. So if I launch this in a browser and start resizing the browser, you can see that no matter how I change my browser window, it keeps the same ratio intact. So when I have more vertical space, as you see, there's too much empty space here. So if I had a primary and secondary content, I would probably want to rotate this. And Flutter provides built-in widgets to accomplish this, but I'd like to show you how much control you have with Flutter in terms of controlling these layouts. So I'm going to use a layout builder widget. And what the layout builder widget enables you to do is check the constraints of your container. So I can decide to build different children based on the container's constraints. So if we take this code and simply paste it, and save, you'll see it will do a hot restart in the browser and start vertically aligning to the two areas. So as I play around with my container size, the layout will change to accommodate the constraints. So we can take this and start nesting it, in which case you can have golden ratios, and you can have these layout containers nicely create expressive designs. So the power of Flutter is that you have fine-grained control now. When you do responsive designs, you don't just look at your browser's size, but you can create layouts based on your container's constraints. Back to slides.
Yeah, if we go back to slides, we can take a look at a more practical example of this with the example app Rally. And Rally is one of the material study apps that's based around personal finance. So you can see that the screen is made up of all of these different widgets that all have different kinds of information that are not only presenting different kinds of content to the user, but also performing different tasks for the user. So I'm going to take a look at how that kind of responsive behavior would react in an environment like this. On large screens in Rally, you get this broad dashboard kind of overview feeling where each widget has plenty of space to show the information that it needs to. You've got dedicated space for navigation and also for the alerts on the other side. And as you start to move between devices to something like a tablet, things start to rearrange themselves. So the dashboard widgets that you saw before are now lined up, and alerts still has that reserved space on the side. And when you go even smaller, things continue to change. So the navigation componentry changes from a rail navigation to these customized tabs along the top. And now everything exists in one vertical column, and alerts are still prioritized at the top. So it's important to recognize here that Rally isn't just adapting componentry and layout across sizes, but it's also reprioritizing elements on screen to preserve the user's mental model of how all of this information is related and what the content means. And so we can see in this simpler example how a cohesive navigation structure might work across devices. So you can see on mobile, the app uses bottom navigation, and it seamlessly adapts to rail navigation at medium screen sizes and a persistent nav drawer at larger sizes. So as the screen space increases or decreases, you're also changing the amount of space, the visual weight, the priority, and also the ergonomic qualities that are given to navigational components. And as you heard in the keynote earlier, Flutter is working on making this happen right now.
So as we get closer to a production quality release with Flutter Web and handle more and more use cases, we want to make sure Flutter is a great citizen on the web. And part of this is following web standards and taking advantage of the latest web APIs that are available across these browsers. But most importantly, we want to build it in a way that respects web user experiences. And since we launched the technical preview, we've been working hard on making sure all the inputs, all the widgets behave in a way that users on the web platform are accustomed to. So we have been working on text editing, clipboard support, spelling autocorrect in inputs, things like keyboard navigation. Because Flutter's roots were in mobile, for a long time, there was no need for keyboard navigation or tooltips or hover events. So all of these have been added to Flutter, and we make sure that these get translated and run on the web platform based on standards. So when I talk about Flutter Web to teams at Google, 3 questions keep on coming up over and over again. So the first one is code size. How big is Flutter Web? How big is the material app? The second one I get very frequently is once they see that we are literally using Flutter's same framework, identical framework, to render elements on the screen, they say, oh, you're painting everything. So accessibility must not work. So that's the second one. They ask about accessibility. And the third one is, this is teams that are using Flutter already for mobile use cases at Google. They ask about their favorite plugin and whether we have added web support to it. So to answer some of these, in terms of performance, today a material app written in Flutter is about 300 kilobytes gzipped. It starts around that number. And our team is hard at work getting that number even lower. And this year, we started making changes in the Flutter framework itself to make it much more performant when it comes to rendering on the web. And the performance optimizations we're doing for the web are actually benefiting all of the other platforms. So one of them is retaining layers. So when you update a portion of your application state and call set state, Flutter repaints that portion of the screen. So we made sure that we don't create or destroy DOM nodes inside the browser over and over again as we're painting and updating the UI. So if you have an infinitely scrolling list, it will reuse those DOM nodes as you are scrolling and update their contents. So Liam, how about accessibility?
Right. So to speak to accessibility, we've got a little video here that where we're demonstrating TalkBack, which is already supported on Android, as well as VoiceOver on iOS. And screen reader support for desktop web is currently in testing. So some of the features that you would expect that are already implemented for assistive technologies across platforms include things like UI traversal, traversal order, UI interaction cues like tappable, labels, editable, incrementable, images, live regions, and checkables. But as Ferhat said, it might be surprising to hear that all of this works, given that Flutter is painting everything. So I'm interested to know how it's implemented.
And again, here we chose to go with web standards. For accessibility, we use standard ARIA attributes on DOM elements. So the thing we do differently is we create a separate semantic tree on top of your visual tree. So in many Flutter applications, we found that the number of semantic nodes is a lot fewer than the elements you need to actually render your scene. So we're able to create a much smaller semantic tree and overlay it with ARIA attributes and enable accessibility for the web.
As Ferhat said, everyone's favorite plugins are the third big question from product teams at Google. And the web has a very rich set of APIs and is constantly adding support for new technologies too. So Flutter for Web gives you access to these APIs through web plugins. And
to give you an example of a plugin, this is the most commonly used plugin in Flutter. It's called Shared Preferences. And it allows you to save and load app preferences on your local device. So if you were to implement this in an iOS project, if you were building a native app, you would use NS user defaults. If you were implementing this in a browser, you would likely use either local storage or IndexedDB to store your settings. And if you are on a Windows desktop, for example, you would use the Windows storage APIs with local settings. So plugins basically give Flutter access to platform-specific interfaces. And in this case, it shields you from all that detail that's under the hood. And you can simply code against the plugin's public interface, use its APIs, and when we compile an AOT binary or we create a JavaScript bundle, these simply work. And if you build your own web plugins to, for example, interop with the JavaScript library you already have, you can easily add these now to your Flutter project by providing them in your pubspec YAML file. So we're happy to announce that we have the first set of plugins now published and available. And a big thank you to our Flutter community. We got great contributions on some of these plugins to make them available to you today. So Flutter is evolving from a mobile framework to cover desktop and web experiences as well. And working with early access partners, we have identified some of the best use cases for using Flutter Web today. So these early access partners are they're dog fooding some of their apps. They're getting very close to shipping their apps into production. And we worked closely with them to both unblock any features they needed to launch and get Flutter Web ready for our beta launch. And the first use case is really simple. If you have a mobile Flutter app today, you can simply recompile it and serve it on the mobile web. The second use case is apps where you create and edit content, typically on a larger screen with a keyboard. But the main app still lets you consume the content on mobile devices. So some of our partners create basically two Flutter apps, and one is primarily for mobile, and the other one is targeted towards laptops and desktops. So the third one we're very excited about is embedded interactive content. This is a great way to add Flutter to your websites today. So you can build rich interactive experiences using Flutter and then host them inside your website.
So we hope that you're excited about Flutter for Web and beta and building rich expressive experiences and all the technical capabilities as well. We welcome feedback, and we really hope that you'll share with us and continue sharing with us the things that you're creating, because we really like to see the beautiful stuff that you're making with Flutter. Thank you.
Thank you.